All right, so we're going to be learning section 5.4, and we're going to do it through a video, which I might make 2 videos. I haven't decided yet. We'll see. One video is going to be for regular problems, and another video would be for the word problems. So I think that's what we'll do, just to kind of sort of divvy it up a little bit. But what we want to look at first is if we have 2 sides of a triangle, can we find the remaining side? So what we've done so far is we've done unit circle trig, where the hypotenuse was 1, except for the last couple of examples that I did on Tuesday. And the hypotenuse was something else. So here is going to be theta. That's our angle measure. We have 4 and we have 1. And I want to find not only the remaining side, but I want to find the 6 trig functions once I find that remaining side. I don't know if you can hear my dog, but she's going insane. Anyway, so what we are going to do is use Pythagorean theorem first, and then we're going to figure out what the sides look like. So I have x squared plus y squared is the hypotenuse squared. So I have an x value, which will be horizontal. So I have 1 squared plus my vertical value, which will be y. Y squared equals the hypotenuse squared. So 1 plus 16 is the hypotenuse squared. So 17 is the hypotenuse squared. We're going to take a square root of both sides. Your hypotenuse, or your radius, whichever way you want to consider it, will always be positive. So normally I would take a positive root and I would take a negative root. But in this case, we're going to take just a positive root. So I've got the square root of 17, is h. So there's the square root of 17. So at this point, we want to label what these sides are. So I'm going to redraw this triangle. So I have this triangle. I have theta here, and I have the right triangle here. The side opposite your theta measure, or your angle, is going to be the opposite side. Okay? You've got 2 sides next to the angle measure. So you've got this side, which is the hypotenuse, and you've got this side, which is the adjacent side. So even though there's 2 adjacent sides, one of them is the hypotenuse and the other one will be the adjacent side. So we're going to look at the sine of theta, and based on the notes that I posted in Blackboard, and based on what I gave you in class on Tuesday, we know that the sine of theta is opposite over hypotenuse. So this is going to be 4 over root 17, which we're going to have to rationalize. So that's going to give us 4 root 17 over 17. Okay, we're going to find the cosine of theta, which is going to be adjacent over hypotenuse. So that's going to be the adjacent side. Remember, there's 2 adjacent sides, but we want the one that's not the hypotenuse. So 1 over root 17. And when we rationalize that, we will get root 17 over 17. We want to find the tangent of theta. So I could do sine over cosine, or I could do opposite over adjacent. So opposite over adjacent will be 4 over 1, which is just going to be 4. And now I can do the reciprocals of all these things. So I've got cosecant theta. Cosecant is the reciprocal of sine. So here's where we want to be a little bit lazy. If we notice right here, before I rationalized, I can flip that thing. Okay? Because these two things are equivalent. So I'm going to flip this one, and I'm going to get root 17 over 4. It'll give me the exact same thing if I flip this one and rationalize again. It just saves me a step. Okay? So secant is going to be the reciprocal of cosine. So again, I'm going to come to this one before I rationalize, because that's going to be the easiest to flip. And that's going to give me root 17 over 1. And I'm too lazy to write the over 1. And then we'll have cotangent of theta is going to be the reciprocal of tangent. Well, here it is before I simplified, or before I rationalized, or whatever I had to do. And there I've got a 1/4. Okay, so let's try this again. We have a right triangle. This is my right angle. This is theta. And this side is 1. And this side is root 26. Okay? So I'm looking for this side. So remember at this point that this is the adjacent side. This is the opposite side. And this is the hypotenuse. Okay? So Pythagorean theorem says that x squared plus y squared will be the hypotenuse squared. So I have 1 squared plus y squared is the square root of 26 squared. Well, a root times itself is going to pop out. So I've got 1 plus y squared is 26. Subtract 1. I get 25 is equal to y squared. Okay? And unless you're told otherwise, just assume that you're in quadrant 1, unless you are told otherwise. So I am going to take a square root of both sides, which is going to give me 5. So this side is 5. If you think about that as being in a circle, okay, so here's the arc of the circle, you would be in quadrant 1 anyway. So this would be the origin, and this would be going up into quadrant 1. Okay, like that. All right, so what do we have? We have the sine of theta. We have the cosine of theta. We have the tangent of theta. We have cosecant theta, secant theta, and cotangent theta. And it doesn't matter the order that I do them in, as long as I pay attention when I'm entering the answers. Okay. So for sine, we're going to do opposite over hypotenuse. So I'll have 5 root 26, or 5 over root 26. I need to rationalize, so that will give me 5 root 26 over 26. Cosine is going to be adjacent over hypotenuse. So we'll have 1 over root 26 will give us root 26 over 26 once we rationalize. Tangent is opposite over adjacent, so 5 over 1, which reduces to 5. Cosecant is the reciprocal of sine. So this is where I'm going to be a lazy math person again and go to where right before I rationalized, and I'm just going to find the reciprocal of that. So I get root 26 over 5. And then same thing here. I get root 26 over 1, which simplifies to root 26. And then cotangent is the reciprocal of tangent, so that's 1/5. So now we have a unique circumstance, and this one you're going to need your calculator for. Remember, you're allowed to use a scientific calculator, not a graphing calculator. Okay? So I am given this triangle. So I've got 75.96 degrees for my theta. This side is 0.5, and this is B, and this is A. Okay, so I know immediately this is the angle I'm interested in. So this is going to be opposite. This is going to be adjacent, and this is going to be hypotenuse. Okay, but what else do you notice is missing? I am missing a second side. So I am going to use what I know about trig functions to figure out that side. So what do I know? I know that I have to figure out opposite or hypotenuse, but I know adjacent. So I am going to choose a trig function that incorporates the adjacent side. Okay? And so for our purposes, I'm going to use tangent theta is opposite over adjacent. Okay, I know the adjacent side, so it's going to be a whole lot easier if my adjacent side is in the denominator. And you'll see why in a second. But that's why I chose tangent. I could have chosen cosine. I could have chosen cotangent. But I would rather choose among cosine, sine, or tangent, because if you look on your calculator, you have cosine, sine, and tangent on your calculator. So it's going to be easier for us to figure that out when we use the trig functions that are readily available. All I would have to do is do 1 over sine for cosecant, 1 over cosine for secant, and 1 over tangent for cotangent, but that's a mess, so I don't want to do that. So that's why I'm going to choose to do these. Okay, so I'm going to choose to do tangent because adjacent is in the denominator, and adjacent is something that I know. So I will now set this up. I know that the tangent of this angle measure is going to equal B over 0.5. So it's the ratio of opposite to adjacent. And now we're just trying to solve for B. So I'm going to multiply both sides by 0.5. So I get 0.5 times the tangent of 75.96 will tell me what B is. So in your calculator, you should have a button that says DRG. That's degrees, radians, and I can't remember what the G is for, gradient, I think. Okay, but we are going to turn it on. We're going to hit degrees, and we're going to make sure degrees is highlighted because we're in degrees. Okay, if radians was what we were working with, I would highlight radians, and then I would press enter. But I'm not interested in doing that, so I want degrees, so I hit enter. And now I just plop this in my calculator. So I've got 0.5 times the tangent of 75.96 is going to give me a decimal approximation of basically 2. Okay, so it doesn't say what to round it to. So we're going to round it just because this is 1.999. We're going to round that to 2. So that means 2 equals B. So this is 2. So now guess what we have? We have 2 sides of a right triangle. If I've got 2 sides of a right triangle, I can find the remaining side using Pythagorean theorem. So I have x squared plus y squared is the hypotenuse squared. So that'll give me 0.5 squared plus 2 squared is the hypotenuse squared. So 0.25 plus 4 is the hypotenuse squared. And then I have 4.25 is the hypotenuse squared. So I can take the square root of both sides. Remember, your hypotenuse or your radius will always be positive. So the square root of 4.25 school just got out, so my dogs are going insane. I get 2.06155. So my hypotenuse is 2.06 because it can't be the same as the other side. Okay, so let's try another one similar to that. So here's A, here's B. This side is the square root of 26, and my theta is going to be 78.69. Okay, so this time I know the hypotenuse. So I'm not going to choose to use tangent, simply because it'll get messy and I'll have to do a lot more work. Okay, but what do I know has the hypotenuse as the denominator? The hypotenuse as the denominator will be either sine or cosine, and we can use either one. So let's write that down. This is opposite. This is adjacent. Okay, this is hypotenuse. So I'm going to choose to use the sine. I could use cosine first. So the sine is going to be opposite, which is B, over hypotenuse, which is root 26. And what did I not fill in? I know what theta is. So now I have the sine of 78.69 equals B over root 26. So I'm going to multiply both sides by root 26. So what I'm going to enter in my calculator is the square root of 26 times the sine of 78.69 will tell me what B is. So again, I'm in degrees, so leave your calculator alone. So I've got the square root of 26 times the sine of 78.69. What am I doing? Okay, and I get 4.9999999, so that's going to be 5. So I know that this side is now 5. So I know two sides of a right triangle. So I can use Pythagorean theorem to find the remaining side. So x squared plus y squared is the hypotenuse squared. That's going to give me, I'm looking for A. So a squared plus 5 squared is the square root of 26 squared. So a squared plus 25 is 26. A squared is 1. You cannot see. So I'm going to take the square root of both sides, so I get A equals 1. So that means that this side is 1. Okay? All right, I'm finding more problems. Give me a second. Okay, so let's get a little bit more exciting. Same process, we're just going to have to do it twice. So I have this triangle. I've got this vertical measure that is 1. And those are right angles. I'm also told that this theta is 11.31 degrees. And this theta is 14.04 degrees. Hang on, I'm going to yell at my dogs. Good, they're outside now. Okay, I want to find the length of this entire red side. So let's highlight it first. The length of the yellow side. So I'm going to break this up into two triangles. And we're going to find this side first. And then we're going to find this side second. And then we're going to add them up. Okay, so triangle number 1 says that this is 11.31. And this is a height of 1. Okay. And we want to figure out what this side is. So what do we know? We know opposite, and we want to know adjacent. So what is opposite over adjacent? That's tangent. So the tangent of theta is opposite over adjacent. So what do I know? I know the tangent of 11.31 is going to equal 1 over the adjacent side. Okay? So we're just going to take one more step for this one. So I am going to multiply both sides by the adjacent. So I have the adjacent side is the tangent of 11.31, and that equals 1. And now I'm going to divide both sides by the tangent of 11.31. Okay, so this reduces, and I'm left with the adjacent side will be 1 over the tangent of 11.31. Okay, so I'm going to slap that in my calculator. So remember, this is the same thing as cotangent, but you don't have a cotangent button, you have a tangent button. So what I've got is the adjacent side is 1 over the tangent of 11.31. So I get 4.99999. So that's going to be a length of 5. So this length is 5, which makes this length 5. Okay. Now I want to know this length. So I'm going to just do the process again. I'm just going to use this triangle with it instead, and then I'm going to add up the two green numbers. So what I have is this triangle, which gives me a height of 1, an angle measure of 14.04, and I'm looking for the adjacent side. So this is going to be tangent again. So I have the tangent of theta is opposite over adjacent. What do I know? I know the angle measure equals opposite is 1 over adjacent is what I'm looking for. So I'm going to multiply both sides by the adjacent. I'm going to divide both sides by tangent of 1404. So this gives me, any number divided by itself is 1. These two reduced. Okay, so I'm left with the adjacent side is 1 over tangent of 1404, which is the same thing as cotangent, but we don't have a cotangent button. Okay, so 1 over the tangent of 1404 gives me 3.9988, so that's going to be basically 4. So now I know that this is 4. So what is the length of the highlighted side? The length of the highlighted side is 9, because 5 plus 4 is 9. Okay, so let's try another one. So we have a triangle inside of a triangle. So this is a right triangle. This is given as 2. This is given as 26.57. That angle measure is. And this angle measure is given as 1843. And we are trying to find the length of this side. So the highlighted side, which I'm also going to color in as red, just to really differentiate it, what's going on. All right, so what's my strategy? If I can find the entire side, so from here to here, which will be this big triangle, and subtract off the smaller side, which will be this interior triangle, I'll be left with the highlighted part. So I'm going to find the big side first, which is going to be in green. Okay, I'm going to find that entire side, and I'm just going to go ahead and draw this again. So this is 18.43, and this is a height of 2. So I'm going to find the big side first. So what do we know? We know opposite, and we're trying to find adjacent. So what do we know about opposite and adjacent? That's going to be helpful with tangent. So we have opposite over adjacent. Okay, so what do we know? Tangent of 18.43 is going to equal 2 over the adjacent side. So I'm going to multiply both sides by the adjacent side. And then I'm going to divide both sides by tangent of 1843. So the adjacents reduce, the tangents reduce, so I'm left with the adjacent side is 2 over the tangent of 1843. So what do we know again? This is the same thing as cotangent, but our calculator doesn't have a cotangent button. So I've got 2, nope, apparently I don't. 2 divided by the tangent of 1843, and I get 6. So this entire side is 6. Now we're going to do the same thing, but we're going to find the orange side using that smaller triangle. Okay, so the full side is 6 units long. We're going to find this orange part now, so I'm going to draw another triangle. So this triangle has a height of 2, has an angle measure of 26.57, so 26.57, and I'm trying to find the adjacent side. So if I'm looking for the adjacent side, and I know the opposite side, that means I'm going to use tangent. So tangent theta is 2 over adjacent, or for lack of room, we have the tangent of 26.57 equals 2 over adjacent. So if you haven't noticed yet, the tangent and the adjacent flip-flop locations. And the only reason I'm showing you that this way is because I'm out of room. Okay, So that gives me the adjacent side is going to be 2 over the tangent of 2657. Okay? So in my calculator, I have 2 divided by the tangent of 26.57, and it thinks, and it's roughly 4. Okay, so this little part right here is 4. So if the big part is 6, and if the little part is 4, that must mean that the yellow part that I'm looking for is 2. So the length of this side right here is 2. So I couldn't do it this way because that is not a right triangle. Okay, so I couldn't use anything from that method right there. But using 2 right triangles, I was able to find the answer. All right, let's do a couple more just to make sure we have this down, and then I'll come back with a second recording of the word problems. Okay, so first of all, I have a right triangle. This is my theta. This is A, and this is C. And I'm told that A has a length of 3. And I'm told that the length of C is the square root of 58. So I want to evaluate all 6 trigonometric functions, which means I need to complete this triangle. So lucky for us, we know the Pythagorean theorem. So x squared plus y squared is the hypotenuse squared. So I have 3 squared plus y squared is the square root of 58 squared. I have 9 plus y squared is 58. Subtract 9, and I've got y squared is 49. So square root both sides. Y squared is, or sorry, y is 7, not y squared. Y is 7. Okay, so what do we know? We know that the sine of this is opposite over hypotenuse. So the opposite side over hypotenuse. So 7 over root 58. I'm going to rationalize, and I'll get 7 root 58 over 58. Remember, this is going to come in handy in a second when we do cosecant. So let's do cosine theta. That's going to be 3 over root 58. So I'm going to rationalize, and I'll get 3 root 58 over 58. And remember, this will come in handy. I know that the tangent of theta is opposite over adjacent. So opposite over adjacent will give me 7/3. And now the rest of these, cosecant theta, secant theta, and cotangent theta, are just going to roll on out. So what do we have? Cosecant is the reciprocal of sine. So I get root 58 over 7. Secant is the reciprocal of cosine. So I get root 58 over 3. Cotangent is the reciprocal of tangent. So I get 3/7. Okay, so let's find another one, or let's do another one. Another type of practice. So we have a triangle, big surprise. We have A and we have B, and we have theta. And we are told that the hypotenuse is a length of root 29, and theta is 68.1986 degrees. So you're in degrees. That's going to be important. And I just want to find the lengths of these two sides. So what do I know? I know that tangent is opposite over adjacent, which I don't have. I know that sine is opposite over hypotenuse, which I do have. I know that cosine is adjacent over hypotenuse, which I do have. So I just need to choose between sine and cosine. It doesn't matter which one you do, as long as you assign the side the correct side length. Okay? So what we have is, I'm going to use sine. I could use cosine. So I have opposite over hypotenuse. So this gives me the sine of 68.1986 is going to be b over root 29. Okay, so another way of thinking about this is I can cross multiply. So I have b equals root 29 times the sine of 68.1986. So this one was easier because the side length that I knew was in the denominator. All right, so I have root 29 times the sine of 68.1986, and I get a side length of basically 5. So b is 5. So I'm going to find out what a is using Pythagorean theorem. So I've got a squared plus b squared is c squared. So a squared plus 5 squared is root 29 squared. Not plus. I mean, it is plus. Plus. A squared plus 25 is 29. Subtract 25, and I get a squared is 4. Take a square root, and I'll get a is 2. So this side will be 2. Okay, so the next video I will go through and we'll do all the word problems together so that you've got a good foundation for that. So I will see you in video number 2.